Hey, fellow problem solvers, Colfax Math here. Calculus problem, finding derivatives and finding the line tangent to this function at this point. It's a pretty long function here. What we need to do is come up with a line y equals mx plus b, and then we're going to use that point where that is. So the first thing we're going to do here is we're going to find the derivative of this, which is the slope. We're going to use the power rule. So f prime of x, I bring that 3 times the 2, 6x, subtract 1 from there, plus, bring that 2 down, 6x, 2 minus 1, negative 5. So that's the derivative of my function, or the slope of my function. Now that I have my slope, I'm going to take this value x equals 2 and find the slope at that point of 2. And all I'm doing there is plugging that 2 in to get 2 squared plus 6 times 2 minus 5. Exponents first, 4, 24 plus 12 minus 5, 36 minus 5, 31. So I know the slope of my function is this. At the point 2, my slope is equal to 31. I could just use my equation for a linear function, y equals mx plus b, and I have my slope, so that 21 just goes in for m. However, to solve for b, I need a point on my graph. So the way I'm going to find that point on my graph, I need a corresponding y value in my function. So I'm going to find f of 2, which will be y. So I'm going to take that 2, plug it in here. That's going to give me 8 times 2, 16. 2 in here is 4 times 3 is 12. Minus 5 times 2 plus 6. So 28, 18, 24. So when x is 2, y is 24. So now I have a point on my graph, right? When x is 2, y is 24. That's a point also on my line of tangency. So I have that value for x and y. I'm going to plug that in for x and y with this slope. So when y is 24, my slope is 31, and my x is 2. One equation, one variable. I could solve for b. 24 is equal to 62 plus b. Subtract 62 from both sides to get negative 38 maybe. 50, yeah, negative 38. So I have a value for m, value for b. A line tangent to this graph at 2 is going to be y equals mx plus b, where the slope is 31, x plus b, 38. We can kind of see that graphically in Desmos as well. So here I am in Desmos. Red is my function. Blue is my derivative, the slope of my function. And if I scroll in to 2, see here, go scroll in more. At 2, I'm at 31. So that kind of makes sense. So again, the blue graph is a graph of the slope, and those are all the critical points. I could see the slope of my actual function, red, is positive, 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 until the slope's 0. Then the slope is negative until the slope is 0, and then the slope goes positive again. So that's how you find a line of tangency at a point on a function.